Okay, let's take a look at this word problem together. If you haven't already done so, now would be a dandy time to actually pause the video and attempt it yourself before we try it together. Okay, so let's take a look at this word problem and remember our problem-solving steps. The first step is to read the problem. I'm going to assume that you've already done that. So let's continue on to the next step, which is to determine what kind of problem it is and see if there's a diagram, a useful diagram, that we can use. This problem has a couple of things associated with it. I'm just going to highlight a couple of things here. You can see that Sean is cleaning the living room, so that's a task in a certain amount of time. So that to me implies that it is a work equals rate times time problem. So there's not really a good diagram for that. So let's move on to step number 3. Step number 3 is to declare our variables. Now I'm going to do that using the table method. And so if my variables are in a clearly labeled table, then I don't have to use a let statement if I don't want. So let's actually take a look at what our table would look like. And so, as usual, I'm going to write across the top my equation, which is that work is equal to rate times time. And then down the left-hand side, I'm going to write my cases, which is Sean, the toddler, and then together. Now, if you like, this would be another good time to pause it and see if you can fill in the blanks in the table. So what is the task they're doing? The task is to clean one room. I'm just going to write that down. Task is to clean one room. So Sean's work when he's working alone is cleaning one room. And even though the toddler might think they're helping in cleaning one room, they're really destroying the room. So for consistency's sake, we can write that the toddler is uncleaning the room with a negative sign. Then when we look at the case of the two of them working together, we have to decide, are they cleaning the room together or are they essentially destroying it? And if you take a look at the original question, which says that they start out with a perfectly neat living room and then turn it into a complete shambles, I think you can see that they are destroying the room together. And so their work together is again uncleaning the room. Now for the time, I can either say that Sean's time is t or the toddler's time is t. I don't know either of them at this point. The nice thing about letting the toddler have time t is that Sean's time is then t plus a half, and I don't have an extra negative sign to worry about, and this is a good strategy if you tend to drop negative signs. And of course together it takes 6 hours. Of course, keeping a toddler in task for 6 hours is not particularly realistic, but I was trying to make the numbers work out nicely. Okay, so let's take a look at the rate. Remember, the rate is going to be the work divided by the time. So Sean's rate is going to be 1 over t plus a half. Don't worry about the fractions right now. We'll deal with them later when we've got our equation set up. The toddler's rate, don't forget the negative sign, is going to be negative 1 over t. And together their rate is going to be negative 1/6. So now would be a good time to pause it and see if you can set up the equation. I'm going to scroll down a little bit here. Oops, didn't mean to go quite that far. There we go. Now because they're both working at the same for the same amount of time, I can just add their rates. So my equation will be Sean's rate, which is 1 over t plus a half, plus the toddler's rate, which again is negative, is equal to their rate together, which is negative 1/6. And if you like, you can stop and see whether or not you can solve this equation for yourself. Let's pause and take a look at it. We've got 1 over t plus a half minus 1 over t is equal to negative 1/6. Now I'm going to scroll down a little bit. and then solve this guy. Because this is an equation, we can multiply both sides by the LCD, which in this case is 6t onto t plus a half, multiplying both sides. And for the first term, the t plus 1/2 cancel, giving me 6t. The second term, the t's cancel, giving me 6 on a t plus a half. And then on the right side, the 6's cancel, leaving me with negative t onto t plus 1/2. So now I'm going to multiply through, and I'm going to get 6t minus 6t minus 3 is equal to negative t squared minus 1/2 t. I can collect everything on either side. I'm going to move everything to the left because then my t squared term becomes positive. So get t squared. Notice how my two 6t terms are going to cancel here, and I'm going to be left with t squared plus 1/2 t minus 3 is equal to 0. I don't really want to AC that because of the fraction, but again, because this is an equation, I can multiply both sides by any non-zero number that I like, and I'm going to choose 2 here to make that fraction go away. So I'm going to be left with 2t squared plus t minus 6 is equal to 0. And if you wanted, now would be a good time to pause this to try to actually factor it for yourself. Okay, I'm going to scroll down now. Now I'm going to AC it. My AC is equal to negative 12, and now I have to write down all of the pairs of numbers that multiply together to give 12. So 1 and 12, 2 and 6, 3 and 4. They're going to be opposite signs, and I want them to add together, give a positive 1. So that's going to be my pair of numbers. And remember, I can't just use my shortcut because here our leading coefficient is not equal to 1. So I'm going to have to go and actually factor by grouping. 2t squared. You can do either the negative 3 or the positive 4 first. I'm lazy, so I'm going to choose the positive 4 because it's a little easier. Now I'm going to factor a 2t out of the first two terms, leaving me with t plus 2, taking out a negative 3, leaving me with t plus 2. And you can see the hallmark of successful factoring in that my binomials and brackets here are the same. So this gives me 2t minus 3 onto t plus 2 equals 0. So t is equal to 3/2 or negative 2. Now those are the solutions to the equation. What are the solutions to the word problem? It doesn't make sense in this context to have a negative time. So I'm going to cross that off. And I'll remind you that this is the toddler's time we just found. And so Sean's time is a ½ hour longer. So 3/2 plus 1/2 is equal to 4/2, and that's 2 hours. And then our special concluding step is to write our concluding statement, which is that Sean, when working alone, takes 2 hours to clean the living room. And now we're done.